everything you need is on your desk folder. Your homework. Go home. Desk down.
I love it. I just want to like my second place.
All right, now. I'll give you in a second. So, write down our homework. I have the close up here from Mystery Science. We got a couple extra minutes. We're going to watch that before we start totaling up our points. You should fill out your recess section of yourself in that. Then as this is playing, we'll come around to fill in ours.
When we did this activity, we decided to do our 4 setups like this. We had 2 setups that had cold oceans. In one of them, we had a cold sky, and in the other one, a warm sky. Then we had 2 setups that had warm oceans, and in one of them, a warm sky, and the other, a cold sky. So which one of these setups
I sneeze really loud, that's the thing about
on the sky phone?
You'll get to know that about me.
2 setups that had the warm ocean. Why would that be? Well, actually, that makes a lot of sense based on what you know, doesn't it? The warmer that water is, the more of it evaporates, or turns from liquid water to water vapor. The warmer the ocean, the more water vapor you get that rise above the air. But the ocean is very different. When we see warm ocean setups, one of them has more water vapor. If you lift the bottle off the ground and look at the lower half, there's lots more water on the lower than the cold sky. Where the sky is coldest, the most water drops form. If you tap it, you can even make it rain. So, let's summarize. What does all this mean?
Excuse me.
The water needs to be warm in order for there to be much water vapor in the air. You hopefully already knew that even before you did the activity. But what is it that turns water vapor back into liquid water? What is it rising off the coast of the river to become liquid water again? The answer is the cold sky. It took something cold to turn water vapor into water vapor. So in order to make it rain, you really just need the opposite of evaporation. With evaporation, you take a liquid, you get it warm, and that turns it into a gas. With the opposite of evaporation, you take a gas, get it cold, and that turns it back into a liquid. This process has a name, condensation, and it is the opposite of evaporation. To make rain, you need condensation to happen. Something cold has to chill the water vapor in the air around us, causing that to become droplets of liquid water that then can fall from the sky as rain. What you made in the activity is actually a model of how rain works in the real world. Sunlight heats up the liquid water of lakes, rivers, and oceans, causing some of it to become water vapor. Then, as some of that water vapor floats around and makes its way up the atmosphere, well, guess what the temperature is like?
What is that?
It's cold. Does that surprise you? Sure, you probably know that hot air rises, but as it does, hot air doesn't stay hot forever. It cools off. And yes, you are technically closer to the sun when you're up there. But the sun is 93 million miles away from us, so you're not closer to the sun in any real meaningful way. If you've been on an airplane, you might have seen for yourself just how cold it is up in the atmosphere. Ice crystals form on the outside of airplane windows. Or you might have noticed that lots of mountains have snow on top of them. Often even when it's warm on the ground at the base of the mountain. That's because it's cold up in the atmosphere. But now wait a second. Let's go back to a question we asked before we did our experiment. Why wasn't Pat's brother getting any rain? He lives in California, sunny, warm California, right next to an ocean. Shouldn't there be plenty of water vapor rising up, hitting the cold atmosphere, and turning to liquid water? Shouldn't he be getting plenty of rain? Well, but there's one piece of information you're missing, and that's what the ocean temperature is like. The coast of California. If you're from California, or if sure, California is famous all over the world for being a land of sunshine and palm trees. But surprisingly, if you visit the beach and you dip your toe decompose in the ocean water. You'll find out. Ocean water off the coast of California is pretty chilly, usually around 60 degrees Fahrenheit. That's 16 degrees Celsius. It's cold enough that surfers in California have to wear wetsuits in order to keep warm. So the problem in California is that there isn't enough water vapor being created by the heat of the sun. The ocean is just too chilly there. Because of this, California tends to be a pretty dry place. If you wanted to make it rain more in California, one way to do it for sure would be to heat up the ocean. That would create a lot of water vapor, and then when some of that water vapor hit the cold atmosphere, it would condense and form rain droplets. So why don't people do this? Well, heating up a whole section of the ocean, that would be very hard to do. That's a huge space. And even if there were a way to do it, there wouldn't be enough heat. And that would be money. So far, an idea like this just wouldn't make sense. Unfortunately, it's pretty rare that anyone in California would run out of water. And that's because every few years, water vapor does arrive in California from air currents that blow over from the warm waters